Today we're going to be finding the nth root of different polynomials. So just like finding the square root is the opposite of finding a square, the nth root is finding the opposite or inverse of finding some number to the nth power. So you'll see if we have x to the third power equals 64, then the third root of x is going to be 4, because 4 times 4 times 4 is 64. So the third root of 64 is 4. If we have some number to the fourth power 625, well, that's 5 to the fourth power. So the fourth root of 625 is going to be 5. It's going backwards. And so you see this pattern continues. Now here's some vocab for you. Right here is the nth root symbol right there. That's actually called the radical sign. And the number underneath the radical sign is called the radicand. And that power that you're finding of is called the index. So we can find an index of 5, an index of 2, an index of 3, all of those. Now in a typical square root, is there an index? No, it's kind of hidden in there. It's actually a 2. And then once you start seeing third roots, it looks kind of like that. So that's an index of 3 of like 27, which is 3, and so on and so forth. So when there's more than one real root, and n is an even number, meaning my index is even, the non-negative root is called the principal root. And that's an important vocab word that we'll talk about a little bit more later. So here's some interesting observations about the index n. If the index is even, 2, 4, 6, 8, so on and so forth, if we have a being greater than 0, then we're going to have a unique positive and a unique negative real root, meaning we'll get a plus or minus, positive root in the principal root. If a is less than 0, meaning it's negative, and we have our index being even, there are no real roots. And finally, if a is 0, then we have one unique root, and that is 0. If our index is odd, 1, 3, 5, so on and so forth, we get one unique positive and no negative real roots. If a is less than 0, meaning it's a negative number, we only get one negative root and no positive. And again, if we have a equals 0, we get one root of 0. So let's look at a couple examples. First, we have plus or minus. Okay, the index in this one is 2, and we have 16 y to the fourth as our radicand. So what I'm going to do is, first off, since it's plus or minus right on the outside, I'm going to put plus or minus for my answer as well. Then I take the square root of 16. Square root of 16 is 4, and y to the fourth divided by 2, because remember we take power to a power, that's like 1/2. So half of 4 would be y to the second. So my answer to this one is plus or minus 4y to the second. Letter B. Since it's negative on the outside, I'm going to have a negative in my answer. Then I look right here. Well, all of this is in parentheses. So I just have to look at this root right here. And so since the index is 2, I take half of 8. So half of 8 is 4. So this is going to be negative x squared minus 16 to the fourth. And that's my answer. For letter C and D. Letter C. I have my index being 5. So what I'm going to do is I'm going to go 243 to the 1/5 power. And I can do that on my calculator. 243 to the 1/5 power ends up being 3. Then I'd say a to the 20th power times 1/5. Okay, so 1/5 of 20 is a to the 4th. And then b to the 25th power to the 1/5 would be b to the 5th. And there again is my answer. Letter D. The square root, index is 2, of negative 16, x to the 4th, y to the 8th. And so you'll notice that back when we talked about square roots of negative answers, that was going to be an I. So the square root of negative 16 is 4i. Then we do half of x to the 4th, which is x squared, and half of y to the 8th, which is y to the 4th. There is my answer there. Guided practice, you can try these if you'd like. Now example 2 is when we start taking into account that principal root. Now in letter A, we're looking for the fourth root of y to the fourth. Now notice it doesn't say whether y is positive or negative. And so to make sure that we don't accidentally have a negative y to the fourth, what we're going to say is we're just going to take our answer as the absolute value of y, because y to the fourth to the 1/4 ends up just being y. But we put it in absolute value because we can't account for if that's positive or negative. So if we put it in the absolute value, it does not matter whether it's positive or negative because our answer is still going to be the same. Just like also in letter B, we're looking for the sixth root of 64, and then in parentheses, x squared minus 3, all of that to the 18th power. So we're going to take 64 to the 1/6 power. And I can do that on my calculator, and that's just going to be 2. And now here, this value right here, we don't know whether that's going to be a positive or negative answer. So I put that into my absolute value, and I'd say x squared minus 3, and then 1/6 of 18 would be to the 3rd power, and I keep that in my absolute value. Again, because I'm not sure whether that's positive or negative, and so we just find that as our principal root. There are a couple guided practice problems on the bottom that you could try. Again, since both of them have an even index and we're unsure whether the variable is positive or negative, we put our answer into absolute value that has the variable in it. Last problem, example 3. This is a real world problem. It says if c is equal to the fifth root of b squared, representing the number of collisions, and b represents the number of bicycle riders per intersection, estimate the number of collisions at an intersection that has 1,000 bicycle riders per week. So what that's saying is that 1,000 is actually our b value. So our collisions are going to be equal to the fifth root of 1,000 squared. So what is 1,000 squared? Well, 1,000 squared is going to be 1,000,000. And so I take the fifth root of 1,000,000, I go to my calculator. Calculator says it's approximately 15.85. Alright, so in letter B it says if the total number of collisions reported in 1 week is 21, estimate the number of bicycle riders that pass through the intersection. So for this one we know what C is, and C is 21. So I set up my problem like this. 21 is equal to the fifth root of b squared. Now, how do we undo a fifth root? Well, it's just like we undo a square root, we put it to the fifth power. And so 21 to the fifth power is a big number. It's 4084101, and that's equal to b squared. How do I get b by itself? Take the square root of that number, and so b is equal to 2,000, and we'll round it to 21 because you can't have 9/10 of a person. So that would say that there'd be approximately 2,021 bike riders that day.